Over to Dr. Murali Bashu.
Very good afternoon. So we start the next session, which is on breast cancer. And we all know that there is a very important association between ethnic variations and cancer predisposition as well as response to therapy. In India, we know that many of the cancers we find a lot of differences from the Western literature, and we know that one of the important reasons is, of course, the genetic variation that is present in any ethnicity, which is also a causal for the variations in cancer disparities. So the first speaker is Dr. Brittny D Lynn from the NIH. She is an independent research scholar from the Division of Cancer Epidemiology and Genetics. She is a PhD and also has an MPH degree. Her research is focused on understanding breast cancer etiology, and she is a recipient of several honors, including the 2020 National Institute of Minority Health and Health Disparities William G. Coleman Jr. Award. She'll be giving a talk on racial and ethnic disparities in breast cancer etiology and progression in the US and abroad. Dr. Lynn, please.
Okay, good afternoon, everyone. I want to thank the organizers for inviting me to give this talk. I'm very honored to be here and talk to you about my research. So GlobalCan 2018 shows us that breast cancer is among the top 5 most commonly diagnosed breast cancer types worldwide. We see it's number second in incidence and 5th in breast cancer cancer mortality worldwide. And when we look at breast cancer incidence rates in the US, the US is among the highest worldwide. And we can see also, we'll focus in on India, which is actually pretty low compared to North America and Western Europe, and also parts of South America. And if we focus in on the US, the 2019 estimates show us that breast cancer is the leading cause of cancer, cancer type, and the second leading cancer type of cancer death among women in the US. And we know that breast cancer is heterogeneous. There are 4 well-acknowledged genomic subtypes based on estrogen receptor status, as well as human epidermal growth receptor 2 status. And so you can see here on the right where we see that luminal A breast cancers account for 73% of those cancers with an ER positive and HER2 negative status. And then 12% are triple negative, not only defined by ER and HER2 status, but also progesterone receptor status. And as I've noted here, you can see that the ER-positive breast cancers are the later age at onset breast cancers. They're also more indolent, less aggressive. The ER-negative breast cancers are more aggressive and have an early age at onset. And if we know that age is the most important risk factor for breast cancer, so if we look at the distribution of the frequency of cases, you can see that we have peaks at age 50 and age 70 when we look at all breast cancer types. But when we look at this by ER receptor status, we can see that there's a peak for age 50 for ER-negative breast cancers, and then we have a higher peak here at age 70 for the ER-positive. So that sort of verifies for us that later age at onset for ER-positive and early age at onset for ER-negative. And we know that there are also geographical disparities within the US. And so Kashev showed us something similar yesterday where we saw highest obesity rates in the Southeast, where we see something similar, of course, for ER-negative breast cancer, where we have these more aggressive breast cancers really impacting women in the Southeast. Oh.
Just plug it together, like this.
Like that? Can you all hear me better now when I turn? Okay. So there are racial disparities in breast cancer incidence and mortality as well within the US. So the highest incidence rates are known to be among the non-Hispanic white women, followed by non-Hispanic black women, but then we have higher mortality rates among non-Hispanic black women compared to other races. And when we look at the frequency of cases again here by race, we can see that the highest peak for Black women is at age 50, so they're experiencing those early age and onset breast cancers. And we see our higher peak here for white women at around age 70, where they experience the highest incidence of those ER-positive breast cancers. And then here you can see in each age group, Black women do have the highest incidence of triple-negative breast cancers across the board. And so this leads us to a couple of research gaps that I'll try to address today in my talk. How are breast cancer incidence rates changing in the US, and what will they look like in the future? And so I think it's important that in order for us to address outstanding research questions regarding racial disparities in breast cancer, it's important to have an accurate description of what we're looking at. And then how do known risk factors impact racial and ethnic specific breast cancer risk? So much of what we know about, which has been touched on before, are from studies that are in populations primarily of European ancestry. So there's definitely a need for more research and understanding breast cancer risk in Black women and other understudied populations. And then at the end, I'll just touch on some opportunities and challenges for studying racial ethnic disparities and breast cancer incidence rates worldwide. And so for this first part, I'll just show some descriptive work that I've done recently. So you all may be aware of the convergence that was reported in 2012 between Black and white women for breast cancer incidence. So it was reported that Black women actually converged with white women and had a higher incidence in 2012. And so we wanted to know how ethnicity would impact this Hispanic ethnicity in particular. And we see that when we actually consider Hispanic ethnicity, we don't get that overlap that we saw in 2012. The rates for non-Hispanic white women are actually just a tad bit higher. And that's because we had this admixture of this Hispanic ethnicity. Hispanic women have much lower rates of breast cancer compared to other women in the US. And this is an important difference because these are totally different. These women have a totally different experience in the US, in particular with breast cancer. We also did some age period cohort modeling that allowed us to forecast these rates. So we can see that in future years, there'll be a slight increase experienced by non-Hispanic white women, a decrease here for non-Hispanic Black women, and then a similar increase here for Hispanic women. And then one of my colleagues, or one of my mentors, Phil Rosenberg, in the biostatistics branch at DCEG showed that ER-positive rates actually have been observed to be increasing among women of all age groups, and he forecasted that this would potentially happen in the future as well, while ER-negative breast cancer rates are decreasing among all age groups. So this is an interesting find, and it's sort of giving us some etiologic clues that we'll talk about a little bit later. But one of the things that we wanted to do was look and see, okay, for ER-negative, is this decrease consistent across all races, across all age groups? And so, excuse me. So we looked at this by race, and we see that there are decreases in each age group, but we also can see that still Black women have the highest incidence rates across all age groups as well. They are decreasing the fastest in this youngest age group, but then the fastest decreases are experienced by non-Hispanic white women for the other age groups. And when we look at this by SEER registry, so the SEER is the Surveillance, Epidemiology, and End Results program that NCI runs. So it's a collection of cancer registries that are run throughout regions in the US. And so this information gets collected. And so for this data is for years 1992 through 2016. And so when we collect this data for looking at 17 different SEER registries, we can see that these are net drifts, or essentially estimated age, or estimated annual percent changes per year. And so you can see that ER-negative breast cancer is decreasing across each race and ethnicity, and also in each of these registries. But when we zoom in on these older age groups, you can see that there's there's more differences here. So we see that places like Atlanta, for Black women, they're not experiencing any decreases. Places like Utah for Hispanic women are actually experiencing increases in ER-negative breast cancer. And if we still look at more regions in the southeast, rural Georgia, we can see that there are also increases for non-Hispanic Black women as well as Hispanic women. And so overall, what I just showed you is just that the breast cancer rates are forecasted to increase for non-Hispanic white and Hispanic white women, but we'll see a slight decrease for non-Hispanic black women. ER positives are increasing. The ER negative breast cancers are decreasing. We see declines across all race ethnicity groups, but there's differences by age, but also by registry. So the next points are basically what risk factors contribute to these racial disparities in breast cancer risk, but then also which risk factors contribute to these opposite trends in ER positive and ER negative breast cancer. And so I'll be focusing on reproductive and anthropometric factors here. And so just to talk about a little bit of this etiologic heterogeneity, so we see that BMI has the most complex relationship with breast cancer risk, where high BMI in the premenopausal state actually decreases risk for ER positive breast cancer, but increases risk for ER negative. And then the opposite is true for postmenopausal high BMI. And then we have risk factors like older age at first live birth, where we see this increases risk for ER positive breast cancer, but decreases risk for ER negative breast cancer. And then there are risk factors like breastfeeding that decrease risk across the board, early age at menarche that increase risk across the board, and then of course this risk factor of increasing number of live births, which again decreases risk for ER positive breast cancer, but increases risk for ER negative. And so I'll just bring back this point that, okay, of course we need to know how these risk factors perform in other populations, and that's my point here. And so people are doing this, so researchers like Julie Palmer in the Black Women's Health Study do work with the AMBER Consortium, which is a collection of cohorts and case control studies pulled together to show these risk factors for black women in particular, and they showed that Paris women who have not breastfed are at increased risk of ER negative or triple negative breast cancer. And so I'll point you to this table. So these are the women that have never breastfed, increasing number of births, and you can see that there's this increase in risk for ER negative and triple negative breast cancers. And we know that breastfeeding definitely differs by race and ethnicity in the US. And in fact, black women have the lowest rates of breastfeeding. But we don't know if this is necessarily the answer. It's definitely a contributing factor. And so now I'll introduce to you the Ghana Breast Health Study, which is a population-based case control study. And so this study enrolled women ages 18 to 74 years in 2013 through 2015 in several catchment areas, 13 districts in Greater Accra, Eastern and Central regions in Ghana, as well as 9 districts in the Ashanti region. And the cases were collected from 3 hospitals, 2 teaching hospitals, and 1 private hospital listed here. And if you have any questions about study design, these are definitely the papers to check out. And so part of the aims for this study were to examine reproductive and anthropometric risk factors for breast cancer for women in Ghana. We know that most U.S. black women are of West African ancestry, so this research is definitely relevant to women in the U.S., but we also see that there are higher breastfeeding rates in Ghana compared to the U.S., so this will help us answer that question of whether breastfeeding is really the answer here for ER negative risk. I'll also show you some estimated age-specific incidence rates from Ghana. So there have been reports of increasing rates of breast cancer in many low-resource country, developing nations. We wanted to follow up, use the study as a way to sort of understand what might be responsible for those increases. There are higher proportions of ER negative or triple negative breast cancers that have been reported, so we'll also try to address that with this study as well. But some of the challenges that we've had to overcome are the fact that there are no existing cancer registries. There's also no breast cancer screening program in Ghana. These are similar situations that appear to be happening in India based on this recent paper. So now I'll focus on the reproductive risk factors. That there's protection in both groups of women based on parity, but there's even more protection for breastfeeding for these women that are older than 50. And then if we focus on just the younger women, we can see that there's higher risk of that early onset ER-negative breast cancer risk for Paris women compared to nulliparous women, but it's counteracted by extended breastfeeding. So again, if we look at parity here, you can see that the ER-negative breast cancers in these younger women, they have a higher risk, but then they get this protection again from breastfeeding. And so, basically just a summary of what I just showed you here, but we know that this is consistent with previous reports in African American women of differential associations of parity and breastfeeding, so I showed you that AMBER consortium study as well. But future studies will examine associations between BMI and other body size variables and breast cancer risk. So some of the opportunities and challenges here, and I'll also touch on those estimated age-specific, those rates. So again, the challenges that we had for this study were that there were no national screening program, no national cancer registry, and then within the study itself, we had inconsistent reporting of sampling unit information. So this was a particular problems for the biostatisticians, but we were able to overcome this a little bit. And essentially what we were able to do was take our number of cases, our enumerated controls. There was a lot of work here done by census workers collecting information about these women. We got census data, some statistical assumptions based on this information since we had this inconsistent reporting of our sampling unit. But we were able to assign population weights to cases and controls. And here I'm showing you this estimated age-specific invasive breast cancer incidence for women based on the Ghana Breast Health Study. And here I'm showing you rates from the SEER program for US Black women. And so you can see that there are lower rates, but we see a similar pattern with respect to risk based on age, right? So there are increasing rates as age increases. And then if we look at the frequency of cases based on ER status, again, we see that similar peak around age, it's a little bit earlier, around age 45 here, and this looks very similar, right, to the peak that we see for Black women in the US. So implications and next steps. So essentially this is just the initial step to gain some etiologic insights for breast cancer in Ghanaian women. And doing those estimated age-specific rates allows us to visualize, but eventually quantify some age interactions between known breast cancer risk factors and age. So those same plots that we did for age-specific rates overall, we can do by different risk factors to understand how risk changes based on these different risk factors by age. We'll also examine associations with BMI, like I mentioned, and eventually we'll be able to build an absolute risk model for female breast cancer in Ghana. And we'll do this using not only the known breast cancer risk factors that I've touched on today, but there is work on looking at a polygenic risk score as well. And so, of course, the ultimate goal is to be able to provide potential targeted prevention strategies for women in Ghana, and then also look at etiologic clues for breast cancer worldwide. And so with that, I'd like to thank my mentors, Gretchen and Monsi, as well as the biostatisticians who were very vocal and super helpful for this work, Phil, Barry, and Parachoy. I want to send a special thank you to the women who participated in the Ghana Breast Health Study, as well as the staff and faculty at these different hospitals who helped us out here. And with that, I'll take your questions.